New Orleans, 95 miles upriver from the mouth of the mighty Mississippi, is one of the world's great seaports. In an average year, it handles a volume of shipping that ranks second only to New York City's among United States ports. But in late summer of 1965, the forces of nature brought the city to her knees. On the night of 9 September and the morning of 10 September, she was struck by Hurricane Betsy, one of the worst storms ever to hit the United States mainland. As the hurricane moved north on a course paralleling the Mississippi, wind velocity ranged from 70 to 105 miles per hour, with gusts up to 160 miles per hour. Tides rose more than 16 feet above normal in a few hours, and rainfall amounted to nearly 6 inches. In her wake, Hurricane Betsy left damage estimated at $1 billion in the port of New Orleans alone. Marine underwriters termed it the most costly natural disaster in maritime history. The largest single Navy casualty was AFDM-2, Auxiliary Floating Dry-dock Medium, which since 1943 had served the port from this shipyard on the Mississippi's west bank in the Algiers section of New Orleans. She had been operated by Todd Shipyards Corporation under lease from the Navy, and in 23 years had docked more than 2,600 ships. With a maximum lifting capacity of 16,000 long tons at zero freeboard to the pontoon deck, AFDM-2 is 544 feet long, and outriggers at each end give her an overall length of 614 feet. She is 116 feet wide, and her overall depth is 52 feet 9 inches. Her light displacement is 6,360 long tons. When the hurricane struck, AFDM-2 was servicing the S.at. Elizabeth Likes, a new automated freighter, shown here docked in a similar facility. As the storm-driven tidal surge roared up the Mississippi, the dry dock was torn loose from its mooring spuds. Still cradling the freighter, she drifted into the river and headed upstream. Next morning, when she was located, AFDM-2 was completely capsized, barely floating, in water varying from 128 to 180 feet deep. The Elizabeth Likes, which somehow had miraculously escaped the dry dock and floated free, was found a half-mile away, aground on the levee, but virtually undamaged. On her erratic journey, AFDM-2 had crossed the 1,100-foot-wide river and gone 3 miles upstream. She came to rest some 300 feet off the east bank. Within hours, salvage experts were studying the situation. In New Orleans, 8th Naval District salvers already were poring over the preliminary report of damage. In Washington, officers of the Naval Ship Systems Command checked the availability of salvage craft and ordered the heavy-duty salvage ships Cable and Curb to proceed to New Orleans immediately. The Cable from its station at Key West and the Curb from its position in the Atlantic off the coast of Jacksonville. In New York, experts from the Marine Salvage Division of Merritt, Chapman & Scott Corporation boarded a plane for New Orleans. By 11 September, representatives from all three were on the scene. They found the capsized dry dock still taking on water and more than 80% submerged. Salvers promptly took steps to keep her from sinking completely. A crew of skilled divers was sent down to determine the extent and location of damage. Surprisingly, their preliminary reports were encouraging. Of the more than 100 holes ripped in the hull during the storm, most were small breaks in the wing walls. Only one break was considered serious, an oval-shaped gash at one end of the center section. Measuring 20 by 15 feet, it probably shipped most of the water that caused the dry dock to capsize. One of the first orders of business was to move the dry dock from the east bank off Press and Mandeville Streets, where she was a hazard to navigation, to the west bank off Vallette Street, in an eddy of a bend in the river. At Vallette Street, divers pinpointed every break in the hull plating and checked the structural integrity of the wall surfaces. They reported the bottom pontoon sections had suffered a few breaks, but were generally in good condition. Internal structural damage seemed minimal. Salvage of AFDM-2 appeared to be technically feasible. But would it be economically sound? Navy and contractor salvers pondered that question. The Navy built AFDM-2 in 1942 for $2,760,000. To replace her at current prices would cost between $7 and $8 million. Salving her would cost considerably less, and since the dry dock was insured for $2.7 million when the hurricane struck, this sum would be available to defray the cost. The alternative to salving would have to be piece-by-piece removal, a lengthy, costly, and dangerous procedure. It became apparent that if AFDM-2 could be salved at a cost that would be within the total insurance funds available, this would be the desirable course. On 23 November, the Navy approved a plan to refloat the dry dock and authorized Merritt, Chapman & Scott to undertake the project. The plan was unique in the long history of Navy salvage operations. Simply stated, the unwieldy dry dock was to be snugged against the river bottom in the capsized position and then rolled up and over through 90 degrees, 160 degrees, and finally 180 degrees toward the river levee, a procedure salvers call parbuckling. The complex plan had the virtue of being designed around individual techniques that had been tested on other large-scale salvage projects. Land-based beach gear, ballasting to alter internal weight forces, compressed air to provide internal buoyancy, and large rubber pontoons to provide a source of external buoyancy. This time, however, all four were to be employed in a carefully predetermined combination. The operation was to be accomplished in 12 stages. As the hull rotated, AFDM-2's basic characteristics, center of gravity and buoyancy and wetted surface, would change constantly under a wide variety of ballast conditions and angles of inclination. So would the stresses and strains on the hull. It would be absolutely necessary to keep the dry dock under constant control during each stage of parbuckling. The Vallette Street site did not meet the conditions called for in the salvage plan. So on 27 November, the dry dock was moved to a site off Pacific Street, 1,500 feet downstream. Here, one wall of the dry dock could be grounded in a depth close to the desired 83 feet, on a reasonably firm bottom with only a gentle slope toward shore. The site offered adequate space behind the levee for the installation of land-based equipment. Offshore, a number of specialized salvage ships had been assembled. The salvage ship Curb, which was to alternate on the project with her sister ship Cable, each equipped with a machine shop, diving locker, towing engine, anchors, pumps, and compressors. 2 Navy lift ships, Salvager and Windlass, assigned to moor AFDM-2. 3 flush deck work barges, obtained from the Army Transportation Service. The salvers equipped these with compressors, welding machines, cranes, and auxiliary equipment. Preparing the dry dock for parbuckling required the services of more than 100 skilled specialists. Workers concentrated on 2 jobs: making repairs to the hull that were deemed necessary, and installing the valves, vents, pad eyes, and other fittings to be utilized during parbuckling. Only those holes that would be underwater during parbuckling would have to be patched. Some repairs below and near the waterline were necessary, however. The many air and ballast intakes and vents required for parbuckling also were installed at this time. 2 8-inch gate valves designed for both the intake and discharge of ballast were installed in each of the 8 center section ballast compartments. 1 8-inch gate valve for flooding in each of the 8 ballast compartments of the end sections, and 2 3-inch globe valves in 2 center section buoyancy chambers. On land, another workforce was busy installing the 16 sets of winch-driven beach gear that would provide a vital horizontal pulling force toward shore of up to 680 tons during rotation of the dry dock. Gasoline and diesel-powered winches acting through a 9-part purchased tackle rigged to cables attached to the dry dock would provide the pulling force. Several hundred feet behind the levee, a tractor-mounted backhoe dug 6-foot-deep excavations for the dead men that would secure the beach gear tackle. The working face of each excavation was lined with 6x6 timbers, and the dead men, which consisted of 4 12x12 timbers 10 feet long, tied together by a wire cable bridle, were positioned. Then the excavation was backfilled. To allow engineers to determine minute by minute whether calculated conditions were being met, for the first time on a salvage project, each beach gear set was equipped with a device to provide continuous reading of the force being exerted. A strain-link tensiometer, developed especially for this project by the Navy's David Taylor Model Basin at Carter Rock, Maryland, was installed between the dead men and standing block of each beach gear set. Direct reading dials at each winch allowed the operator to check the beach gear pull. Stylus recorders in this communications and control center enabled the project engineer to continuously monitor the entire beach gear network. Adjustments were ordered by phone or radio. By mid-February 1966, preparations on the dry dock had reached the stage where the B-wall could be raised for final repairs and inspection. Suddenly, in the pre-dawn hours of 16 February, a surge of water and debris resulting from upstream floods ripped the dry dock from its moorings. Together with the lift ships Salvager and Windlass, AFDM-2 drifted across the Mississippi under cover of dense fog. They came to rest off the east bank near Congress Street Wharf, approximately 1,400 feet across the river and 500 feet downstream of the salvage site. The dry dock had suffered no additional damage, but the job of returning her to Pacific Street was a formidable one. The high level of the Mississippi and strong current conditions were the major complications. In marine salvage, however, a basic truism is that the unexpected generally is to be expected. Within a week, the salvers had devised a plan to return the 614-foot dry dock and began assembling the men and equipment to do the job. It required more than 100 men and 12 ships, the curbs, salvager, windlass, and 9 local tugs. 13 March, a Sunday, when river traffic is light, was picked as the date. The basic plan was to swing the dry dock across the river in pendulum fashion, with a pivot formed upstream of AFDM-2 by 4 anchors planted in mid-river. The arm of the pendulum was formed by cables from the anchors to the salvager, which was moored to the dry dock. Upstream, the curb and a 2,400 horsepower tug were assigned to maneuver the dry dock so as to maintain its longitudinal axis in line with the anchors. 3 pusher-type towboats were positioned at the downstream end for the same purpose. Finally, 2 sets of beach gear planted on the opposite bank of the river were attached to the dry dock to control the swing of the pendulum. With her ballast compartments dewatered by compressed air to float her, AFDM-2 was eased into the channel, where she began to swing on the anchors. In mid-river, however, the strong current caused the anchor moorings to slip, and the winches of the salvager no longer were able to maintain control of the anchor lines. It became necessary to put into effect a prearranged alternate plan of action. 7 tugs and the curb, with a total of 15,850 horsepower, were repositioned in this manner to bring the dry dock under control. They pulled and pushed her toward the west bank, where she was secured off Pacific Street at 1818 hours, just 18 minutes behind schedule. But by now, the Mississippi was approaching its yearly high-level flood stage. Even before the breakaway, engineers had decided to wait until after the annual river crest had passed before undertaking the parbuckling operation. Work on the dry dock was halted for a 3-month period, during which a security crew kept round-the-clock watch on the moorings and adjusted beach cable tensions as the river level fluctuated. By June 15, the Mississippi had fallen to a level that allowed work to be resumed. Welders installed 68 pads for the rubber pontoons, and within a month, all necessary hull repairs had been completed. Now the dry dock was turned end for end to place her in the proper position for parbuckling. The A wall, the one with the large gash, became the offshore wall. It would remain above water during parbuckling. All that remained was the installation of pads for the beach gear cables. Preparations were completed. Salvers were ready to put into effect the carefully engineered 12-stage plan to rotate the dry dock 180 degrees from the inverted position. Stage 1 called for the B wall to be grounded on the river bottom in 83 feet of water. To accomplish this, 18,900 tons of water ballast were added to compartments in the inshore wall, while offshore wall compartments were dewatered. These steps, however, failed to raise the A wall to the desired goal of 46.5 degrees. Keeping the hull from healing were large deposits of dense mud that had permeated many of the compartments, especially in the A wall. For 8 days, mud and water, 2,000 tons of it, were jetted and pumped from the A wall compartments. Slowly, the dry dock rotated until it reached 45 degrees, still short of the 46.5 degrees called for by stage 1, but well within acceptable limits. To reach stage 2, 60 degrees, the land-based beach gear were to be brought into play. It was calculated that a horizontal pulling force of 551 tons applied to the chine line of the A wall would bring the dry dock to stage 2. But this force failed to rotate the dry dock to 60 degrees. Once again, mud was the problem. Divers found a thick layer clinging to horizontal stiffeners within the hull. Its quantity and location were the upsetting factors. Pumps went to work around the clock, and beach gear force was increased to an average of 650 tons. It took 8 days to reach stage 2. The presence of mud was not unexpected. While the engineers' computations had been made on the assumption that comparatively small quantities remained trapped in the hull, they knew this was unrealistic. It was a necessary assumption, however, because it was impossible to determine with any degree of accuracy the location and quantity of mud. The salvage plan had to be based on known factors only, and the engineers realized that field adjustments would be necessary. The angle of the dry dock was now 59.5 degrees. The key to reaching both the stage 3 position, 70 degrees, and the stage 4 position, 80 degrees, was the addition of water ballast to the center sections. On the day stage 2 was reached, 1,400 tons of ballast were added over a 3.5-hour period to the buoyancy chamber compartments adjacent to the midships transverse bulkhead. 26 hours later, the hull reached the stage 3 position of 70 degrees. As the beach gear force was increased to 600 tons, the dry dock rolled steadily to 80.5 degrees from the inverted position, half a degree more than had been calculated for stage 4. Now the operation entered a crucial phase. When the salvage plan was formulated, it assumed a level river bottom under the B-wall as it moved into the 90-degree position. Actually, the salvage site sloped upward toward shore. In the planning stage, engineers realized that the slope could offer enough resistance to the beach gear force to prevent the dry dock from rotating to 90 degrees. Dredging the site to level it before the dry dock was positioned had been considered. However, there was always the chance that the river might wash out enough mud to reduce the slope, or that the weight of the dry dock might compact the mud enough to allow the dry dock to settle. If either action took place, dredging could be avoided. But the hoped-for scouring action or compaction did not occur, and the dry dock held at 83.5 degrees. In a further attempt to eliminate the need for dredging, several operations originally scheduled for later were undertaken. First, 2,500 additional tons of water ballast were added amidships. Beach gear force was maintained at 650 tons, almost 200 tons higher than had been contemplated. Finally, engineers decided to employ the third force, the air-filled sealed bin rubber pontoons that originally were scheduled to furnish an external buoyant lift at stage 6. Similar collapsible pontoons have been used on salvage projects before, but never in this quantity, nor in this manner. This salvage plan called for a total external buoyant lifting force of 600 tons to be applied by 68 pontoons attached to cables secured to the weather deck of the B-wall. The 3/4-inch thick rubber pontoons were 8 feet high and 7 feet in diameter when inflated. Each provided a buoyant force of about 8.5 tons. They were not completely sealed. A 9-inch diameter opening at the bottom provided access for air and venting. On 11 August, with the first 10 pontoons in place, 800 tons of ballast were added. Next day, 15 more pontoons were installed and 500 additional tons of ballast taken on. 31 more pontoons were attached in the next 2 days, but still the dry dock failed to heal. Dredging was necessary. On 15 August, a dredge began to cut a trench extending along the shoreward chine line about 2/3 the length of the dry dock. The trench, 15 feet wide and 10 feet deep, was completed in 2 days. As the dredge pulled away, the beach gear sets were stressed to pull the dry dock into the trench. Within hours, it rotated through the critical stage 5 position of 90 degrees, through stage 6, and reached 100 degrees, stage 7. Meantime, the beach gear force gradually dropped until at stage 7, only 250 tons were required to hold the dry dock in equilibrium at 100 degrees. The following day, this pull was increased to 315 tons. The dry dock came easily to 109 degrees. only 1 degree short of the calculated Stage 8 position. Stage 9 called for the dry dock to reach 120 degrees. On 19 August, after 2,100 tons of water ballast were added to increase the total to the 5,900 tons calculated for this stage, the dry dock rotated to 118 degrees within acceptable limits. Beach gear force was 150 tons, exactly as planned. Now the salvage crew prepared for another crucial period. It was time for compressed air to replace beach gear as the prime force rotating the dock. The plan called for the injection of enough compressed air to blow 560 tons of water ballast from the center section of the B wall. While the center section was being deballasted with air, 2,000 tons of water ballast were added to the end sections on the A wall. The amount and pressure of air in the hull had to meet extremely close tolerances to avoid overstressing the dry dock structure. Back pressure readings were to be 25 pounds per square inch, but not over 26. Beach gear force was dropped progressively from 150 tons to 0. The pontoons had been attached in 3 tiers by varying the lengths of the pendants that held them. This would allow their lifting force to be dissipated in 3 increments of 200 tons each, instead of all at once. As each tier broke the surface separately, the righting moment would be reduced in steps, thus providing an important restraint on the rate of rotation. The stage was set for the righting moment on the dry dock to be supplied by unbalanced forces within the dock, and the external buoyant lift of the rubber pontoons. On 21 August, at 05:30 hours, AFDM-2 started her slow, controlled rise as Tier 1 broke the surface, then Tier 2. By 05:38 hours, Tier 3 and the submerged wing wall came up. The last critical stage had been completed successfully. The dry dock now was afloat at 161 degrees from the inverted position, 1 degree more than calculated for Stage 11. Actual conditions and those predicted by the engineering calculations were remarkably close. Air pressure in the B-wall compartments had been calculated at 6.5 pounds per square inch. Actually, it was 7. Ballast in the inshore compartments was to be 2,605 tons. Actual water ballast was only about 2,000 tons, but approximately 600 tons of mud still trapped in the compartments made up the difference. The offshore chine line was to be 42.5 feet below the surface of the river. It stabilized at 41.5 feet. With the hull in the 161 degree position, the ballast vents were closed and the compartments under air pressure were bled down. 4 days of dewatering slowly brought the dry dock to an upright position. With salvage equipment and accumulated debris cleared from the dry dock, all that remained was to transfer AFDM-2 to a shipyard for further repairs and refurbishment. On 25 August 1966, the salvage ship Cable and 2 local tugs turned her end for end off Pacific Street and began to tow her 2 miles downstream to the Algiers facility from which she had broken loose 11.5 months earlier. Thanks to the successful completion of an imaginative, well-executed salvage plan, AFDM-2 would once again take her place as a valuable ship repair facility in the port of New Orleans.